All right, morning, guys. Like I said yesterday, we're going to do class today, just to finish the last chapter, which is integration. Okay, so we're just going to continue from where we stopped yesterday, but I just brought this out to show you that integration. Okay, see, just a bit of disclaimer: if you hear kids making noise, they are not my kids, but I'm at home, so that's why kids can make noise. Okay, because I can't tell them to stop. Okay, so now if we said that I said integration is the opposite of differentiation. So you can see it here. Integration is the opposite of differentiation. It enables us to get to find the original function, okay, of a derived function. Okay. So if you differentiate to get an answer, you integrate that answer and you get back your question. All right. So that is how integration works. And so you can't know integration without knowing differentiation. Okay. Now you see when we're talking about plus c, you say y plus c. Remember that when you differentiate any constant, the answer of the differentiation is what? 0. Now, when integrating, we're expected to establish what the constant was. This is very difficult. Therefore, we account for the missing constant by simply writing what? Plus c. Now, when you get to n5, you'll be able to do something called particular solution, when you have to calculate what c is. But for your level, whenever you integrate, just write your final answer and put plus c there. Okay, so that is how it works. Because when we differentiate the question, all right, the constant, the differential of the constant is 0. So there might have been a constant there. We never know. But to establish the fact that there might have been a constant, that is why after you write your answer, you just write what? Plus c. Okay, so we listed all the rules yesterday. Okay, we listed all the rules yesterday, but let's do more examples from what we were doing yesterday. All right, so I listed 12 rules yesterday, but now these are the type of questions that you'll be asked in the exam. Like I said yesterday, for all these questions, there are some that you might need to what? Simplify first before you integrate. Okay, simplifying by maybe opening the brackets, simplifying by using your identities. Is that fine? Simplifying by using your identities, like all those things. So there are some that you might need to simplify first before you integrate. Okay, so let's see how to do those ones, all these ones. That's fine. So let's start with number one. Let me confirm this one. I see that it's 4 over x. I think it's a mistake. That should be a mistake. It's November 2016. That should be a mistake. It should not be 4 over x. It should just be maybe 4x. Or maybe it's tan x minus 4 over x or something. Yeah. It's x. So let's correct this. This one on this side should just be 4x. Okay, should just be 4x. So let's do these examples and see how to properly integrate. Like I said, I am recording, so those who are not in class can watch the recording later. Okay, good. So let's start with the first one. All right, so we'll be able to finish everything today because it's 2 hours. Then we will continue from here and do definite integrals and applications of definite integrals. All right, so let's start with the first one. The first one has, so this is the first one. All right, so you see in this situation here, all right, there are two things we need to simplify in this question. Okay, there are two main things we need to simplify. What are those two things? We need to simplify this expression first. before we integrate. Then we also need to simplify this expression before we integrate. Is that fine? Now, how do you simplify this one? We start by opening that bracket. So you have the square root of x, okay? Or you can do this. Let's do this to be faster, right? Let's say the integral x raised to power half over x, then 1 plus x all squared minus 3 ln 2. We don't need to simplify that one. Minus 3x raised to power 10. We don't need to simplify that one. Then plus, here we can simplify it because this is 1 over cosec squared. 1 over cosec squared, okay, times 3 is the same thing as 3 sec squared x, because 1 over cos is what? Sec. So this is 3 sec squared x. Is that fine? Dx. So that is for that one. So we simplified this one to be this. Now we need to simplify this one. How do we simplify this one? We open the bracket. Okay, you can see that the max here is 7. So you are supposed to eventually have what? 7 different answers. Let's see what is happening here. These ones are the same base. Okay, these ones are the same base. So what do you do here? You what? Subtract the exponent. So it's the same thing as, I've not started integrating, I'm still simplifying. It's the same thing as half minus 1 into, let me open this bracket. This is 1 plus 2x plus x squared. Is that fine? Minus 3 minus 3 ln 2 minus 3x raised to the power 10 plus 3 sec squared x. All right, so now what we do is now we simplify this and use this to open the bracket. So half minus 1 is what? X raised to power what? Minus half. Okay. I've not started integrating still. I'm still simplifying that one. Plus 3 sec squared x dx. So let's simplify this one now. How do we do that? We open the bracket. So this multiplies this, and it multiplies this one, and it multiplies this one. Okay, so if you do that, okay, good. So if you do that, what will you be left with? You'll be left with x raised to power negative half minus, or plus, sorry, 2x raised to power 2x raised to power what? Negative half plus 1. Is that fine? Remember, they're multiplying, so you are adding the exponent. Then plus x raised to power 2 here will be what? Negative half plus 2. Okay, negative half plus 2. So you open that bracket, then this is equals, then this one still remains minus 3 ln 2 minus 3x raised to power 10, then plus 3 sec squared x. Three sec squared x dx. Good. So we integrate it. All right. If we integrate this, what will we have? No, first let's do this one. What is half minus 1? Can someone do that on the calculator for me? What is half minus 1? I think it's half, if I'm not mistaken. So you have x raised to power negative half, then plus 2x raised to power half, okay, then plus x raised to power half plus 2 should be 3 over 2, okay? Half plus 2 should be 3 over 2. No, it's negative half plus 1. What does it give? Negative half plus 1. Should be half, okay? Okay, yeah. Then half plus 2 should be 3 over 2, okay? Then you still have all that. Good. So this is what we integrate. That's fine. So you see 1, 2, 3, 4, 5, 6. Then plus C is always a mark back there. Okay. So the plus C as well is always a mark. So that's why I said you must always write plus C. So we can integrate it now with what? Simplified everything. Now, how do you integrate this one, this one, this one? You use the rule number 2. Okay, the power rules, the powers of x. Okay, you use that rule number 2 in the what we wrote yesterday. Rule number 2. Okay, now how do you integrate this one? This one is rule number 1. Okay, the integral of a constant, because there's no x there, so everything there is a constant. All right. So how do you integrate this one as well? You use rule number 2. Okay, rule 2. Is that fine? Then how do you integrate this one? I think is rule 10 or 11, the integral of a sec squared. Okay, I can't remember the number, but that's integral of a sec squared. So let's integrate everything now. So what do we have here? This is the same thing as negative half plus 1 over negative half plus 1. All right, that is the integral of this one. Then here, this one is the integral of this one is 2x half plus 1 over what? Half plus 1. Then this one is x 3 over 2 plus 1 over 3 over 2 plus 1. Okay. Then here is 3 link 2 times what? X, because it's a constant. Is that fine? Because it's a constant. Then here is equals to 3x raised to power what? 10 plus 1 over 10 plus 1. Then this is 3. The integral of sec squared is what? And x plus c. Is that fine? So all you just have to do is simplify and leave your answer the way it is. Okay, so this is equals to x raised to power. If you do this, this should give you what? Half over half plus 2x raised to power. This should be 3 over 2 over 3 over 2. Then plus this should give me x raised to power 5 over 2 over 5 over 2. This one is still 3 link 2x. Then here is 3x raised to power 11 over 11. Then here is 3 tan x plus c. Is that fine? 3 tan x plus c. So that is how to integrate this one. Okay, so that is how to integrate that. 3 tan x. And that should be your final answer. Okay, all you just have to do, you can simplify it more, but they don't really look at that. So what I mean by simplify it more, you can say this is the same thing as 2x raised to the power half is the same thing as 4 over 3 x raised to the power 3 over 2. This is the same thing as 2 over 5 x raised to the power 5 over 2. This one still remains. Okay, this one still 3 over 1 x raised to the power 11. Then this is 3 and x plus c. Okay, so that's 3 over 11 x raised to the power 11. So that's how to integrate. So you need to make sure you simplify properly before you integrate. Okay, you make sure you simplify properly before you integrate. Let's try the second one, number 2. Okay, so with this one, there's only one thing we might need to simplify here, and it's just this one. The rest we can integrate it straightforward. Okay, we can integrate those ones. Is that fine? The only thing we might need to simplify is just this one, looking at this question. All right, so let's see how to do it. Let me just copy the question out. How do we simplify this one? You just, like I said, you see this one, you don't need to simplify it because, like I said, you don't use when you are using this rule, okay? When you are using this rule, please note that n is not equals to -1, okay? When you are using this rule, the power rule, n is not equals to -1 because the integral of 1 over x is always equals to ln x plus c. Or if you have the integral of k over x is always equals to k 1 over x dx, which is equals to what? K times ln x plus c. Okay, so you don't need to simplify the first term. It's only this one we need to simplify. Then when we apply this rule. Is that fine? So let's do it. So we'll have the integral 2 over x minus, if we simplify this, this is x raised to the power of -2 minus e raised to the power minus 4x plus q plus 3 sine x over 3 plus cot squared x dx. All right, so let's start integrating. That was the only thing we need to simplify. So if we integrate now, you can see when you start integrating your sign, that integral sign and the x goes away. Is that fine? So it becomes 2 ln x, then x raised to the power minus 2 plus 1 over minus 2 plus 1. How do you integrate this one? This is e to the power of -4x over -4. Then what is the integral of q? It's a constant, it's just q times x. Then what is the integral of this one? This is 3 sine, the integral of that one will be, I want to put it in a bracket, it will be negative cos x divided by 3 divided by what? 1 over 3. That's fine. Divided by 1 over 3. Because remember, I said the integral of sine is what? Negative cos. Therefore, the integral of sine x over 3, okay, the constant is 1 over 3. So that's why the coefficient is 1 over 3. So that's why it divides here. All right, cool. That's for that one. Then the integral of this one. What's the integral of cot squared? Okay, one of the last rules I wrote is what? Negative what? Cot squared is cot squared. Okay, I think we're supposed to simplify this one as well because the integral of cot squared, I didn't write that one. We're supposed to simplify this. All right. So let's go back a bit. Sorry about that. I didn't see that. All right. So let's just go back a bit. Because I didn't write the integral of cot squared. So that's fine. Now, for this one, how do you integrate this one? You use your identities. What's the identity for cot squared? The identity for cot squared is cosec squared minus 1. Okay, there's the integral of cosec squared, not cot squared. Okay, the integral of cosec squared exists, not cot squared. So you're supposed to use that identity here. So let's do that. So this is, let me just erase this one. Okay. Let me just erase this one so that I can have space. Good. So here will be what? Cosec squared x minus 1, then dx. Okay, there's no integral of cot squared. Okay, there's no integral of cot squared. It's only cosec squared that they have that has an integral. All right. So this is what you are supposed to. So you're supposed to use your identity for this one as well to simplify it. Okay, you're supposed to use your identity for this one to simplify it as well. So now, if you integrate it now, what's the integral of cosec squared? It's what? Negative cot x. Then what's the integral of 1? It's x plus c. Okay, it's x plus c. So we are supposed to what? Apply our identity for this one. Because there's no integral of cot squared. All right. I didn't write the integral of cot squared. So when you have cot squared or you have tan squared, you are supposed to use the identity for both of them. Okay. I can write it as a separate rule just so that you guys have it. Okay, I can write it as a separate rule. So if you are supposed to integrate cot squared or tan squared, you're supposed to apply your identity as well. Okay, so that's our final answer. This should be 2 ln x. Then here will be plus, because this is minus, because this is minus 1, plus x raised to power what? Minus 1. Okay. So it will affect that sign, plus x raised to the power minus 1, okay, because this is minus 1. So it will change this sign. So now, here, this is plus e raised to the power minus 4 over 4. Then this is plus qx. Then here, if you flip this and subtract, it should give you plus 9 cos x over 3. That means if you do 3 divided by 1 over 3. Okay, if you do 3 divided by 1 over 3, it should give you 9. Okay, here will be what? Negative cot x, negative x plus c. And that is the answer. Okay, so if you have the integral, let's just write, what was the last number of the rule I wrote yesterday? What was the last number? Can someone check their notes from yesterday? What number was it? Did I do last?
Excuse me, sir.
Yeah.
Sir, if we left it as the second step, would we still get full marks?
If you left it as what? Second step?
Yes.
Yeah, but if you decide to you must add or subtract all those things. Yeah, you still get your full mark.
Okay, thank you, sir.
Yeah. What was the number of the rules yesterday? The last rules I wrote. What was the numbers? What was the last number there? Who was in that class? Jaden. The last one I wrote. What was it again?
It was cosec 2x cot 2x.
Okay,
and
so
then we got an answer.
Yeah, what was it? Is it 10 or 11 or 12?
I'm not sure. I think 11.
Okay. So let's just assume it's 11. All right, so let's just assume today. So you have 12. If you're supposed to integrate cot squared x dx, what you do is you apply your identity first. Okay, cosec squared x minus 1, okay, is the identity you integrate. So if you integrate this one, the integral of cosec squared is what? Negative cot x. The integral of 1 is what? X plus c. Then if you are supposed to integrate sec squared dx, sorry, not sec squared, tan squared. If you are supposed to integrate tan squared x dx, okay, you apply your identity as well. That is what? Sec squared x, is it plus 1 or minus 1? It's minus 1. It's minus 1. Okay. Then if you integrate this now, this will be what? Tan x minus x plus c. That is how to integrate those two. Okay. That is how to integrate those two. So if you are supposed to integrate cot squared or tan squared, that is how you do it. Then there's also for sine squared, but let me just write it. I don't know if there's a question, but it's mostly for M5. For sine squared, you're supposed to use your identity is what? Half minus half cos 2x. Okay? Half minus half cos 2. I'm not sure if this one is there as well, but let's just write it out in case you get a question like that. You never know with the department. So this one is half x, then minus 1 over 2 sine 2x over 2 plus c. Is that fine? So that's how you are supposed to integrate sine squared. Okay, so that's how you're supposed to integrate sine squared. That is how sine squared is integrated. Okay, so if this is a constant, is half x, then we integrate this one is sine 2x over 2 times that half. Okay, then if you are supposed to integrate, just write the last one. If you are supposed to integrate cos squared x dx, okay, you apply your identity. Your identity is what? Half plus half cos 2x dx. So this is also what? Half x plus half sine 2x over 2 plus c. Okay, so you can do this as well for this. So this is x over 2 plus 1 over 4 sine 2x plus c. Just in case you might be asked, yeah, you never know. But I'm not sure. It's mostly M5, this one. Okay, but just in case. Right, for this ones, you apply your identities for them. So you apply identities for all these ones before you what? Integrate. You apply your identities before you integrate them. Okay, so that is how to integrate cot squared, tan squared, sine squared, and cos squared. Okay, so that is how to integrate those. Good. So let's move to more examples. The last two examples. All right. So you see here we have. Let me just get it, copy it. Number 3. Please try it. What will you get as your answer? Now, remember, with all these questions we've been doing, we are integrating with respect to x, but they might say with respect to t, or they might say with respect to y. The rule still applies. Okay, just know that the same rules apply. They're fine. The same rules apply. So please don't think is a different thing. If you are supposed to differentiate with respect to t here, and everything is in terms of t, you still use the same rules. Okay, remember, it's not a constant. Okay, so if you are supposed to differentiate with respect to t, you look at your d, whatever is there. If it's the t here, you are supposed to differentiate with respect to t. If it's the x, you're supposed to differentiate with respect to the x. If it's y, you're supposed to differentiate with respect to y. Okay, the same rules applies. All right, so with this one, which ones do we have to simplify first? All right, let's see. We need to simplify these ones by using identity. Okay, here we just need to bring that x up. Then here we need to simplify it as well. The remaining are fine. We can integrate those ones. But let's simplify these two first. All right, now how do we simplify this one? All right, this is the same thing as sine. Okay, this is the same thing as sine x over what? Cos x times 1 over cos x, isn't it? Because if you bring it back, you have what? Sine over cos squared. Okay, there's no need to substitute an identity for this, but you see, there are identities for this, and there is identity for this. What is sine over cos? Sine over cos is what? Tan. What is 1 over cos? 1 over cos is what? Sec. And you have an integral for sec x tan x. So you see, this is the same thing as the integral of 2 sec x tan x. Then here is minus 7x raised to power minus 4. I've not integrated, that's why my integration sign is still there. Then here is minus 2x raised to power minus 2. Then here, this one's just cancelled one here. You have what? Plus 5 over x. Then here you have minus 6 times 2, 3x. Then here you have minus 2 cosec squared x. Yeah. So this is what you integrate. Is that fine? This is what you integrate. So how do we integrate sec x tan x? Okay, the integral of sec x tan x, I said it there yesterday. I said is equals to what? Sec x. Okay, so the integral of this one is this. Is that fine? Then how do we integrate the next term? We say minus 4 plus 1 over minus 4 plus 1. All right. Then how do we integrate the next term? This is minus 2 plus 1 over what? Minus 2 plus 1. Then how do we integrate this? This is 5 ln x. How do we integrate this? This is 2 power of 3x over what? 3 times ln 2. How do we integrate this? Remember, all these rules I've given you guys yesterday. Okay, like I said, most of them are not in the formula sheet, so you need constant practice. All right. Okay, you need constant practice, or you write it out in your own formula sheet, then practice. Don't bring it to the exam hall. Okay, but use it to practice. So fine. So it's constant practice that makes you know all those rules. Okay, so that's why I took my time yesterday to write everything out. That's fine. Okay, I think this one is rule number, if I'm not mistaken, is it 4 or 5 there? That's this one here is 4 or 5. This one should be number 3. This one should be 4 or 5 there. Yeah. Okay, then what's the integral of this one? This is negative what? Cot x plus c. All right, then you just simplify your answer and get it. So this is equals to 2 sec x minus 4x raised to the power, no, it should be plus now, because this is minus 3 over what? 3. Is that fine? Then this will also be plus. It should be x raised to the power minus 1. Okay, because that will be minus 1 here. Then this is 5 within x. Then this one is cancels this one. So you have what? 2 times 2x raised to the power 3 over what? Link 2. Then here will be plus 2 cot x plus c. And that is how to integrate that one. Okay, so that is how to integrate that. All together. So this is your final answer. Is that fine? So that is how to integrate this one. All right. Awesome. So the last one, before we jump into the next thing. Okay. That one there. Okay. So you see with this one, there are a few things we have to simplify. Okay. We first have to simplify this. We have to simplify this. This one is fine. Remember I said this is 4x. We have to simplify this one as well. Okay. We have to simplify that one as well. Then we integrate. That's fine. So you see, there are some situations where you might have to simplify by using your identities or by using your normal mathematical simplifications. Okay, to simplify it before you integrate. Okay, what do we want to do? We want to simplify it to the standard form, to all those standard forms I gave you yesterday. That's the main objective, to simplify the question to the standard form before you what? Integrate. Okay, that's what we are going to do. All right, so now let's do that last one, then we'll move to the next best thing. So we're supposed to simplify this one by opening the bracket. This is the same thing as this is the same thing as 9x squared. Like remember I said that this is 4x. Okay, so that is 9x squared. Now if you simplify this, this is the same thing as x raised to power negative 3 over 2. Okay, because this is x raised to power 3 over 2. Okay, that if you simplify that one, it should give you x raised to power 3 over 2. Okay, this is x raised to power 3 over 2. So if you bring it up, it becomes x raised to power 3 minus 3 over 2. All right, so this one is 3 x raised to power minus 4 still remains. Then this is 4 times 4x here. Then here, we need to simplify this. How do we simplify this? We have 1 over what? Cot x cos x. Okay, is the same thing as 1 over cot x times 1 over cos x, isn't it? So what is 1 over cot? Okay, 1 over cot is what? Okay, the one is 1 over cos. 1 over cos is what? Sec. So you can integrate it now. Okay, because this is the same thing as sec x tan x. And we know the integral of sec x tan x. So let's integrate now. This is equals to 9x2 plus 1 over 2 plus 1. Here is x raised to power minus 3 over 2 plus 1 over minus 3 over 2 plus 1. That's raised to power minus 3 over 2. 3 over 3x. Okay, good. So here, how do you integrate this one? Remember, you're just going to integrate this part. Okay, the constant comes down. So this is negative 7 to the power of negative 3x over what? negative 3 ln 7. Okay, negative 3 ln 7. All right, then here is 4 ln sec 4x over. Okay, then here is 3 sec x plus c. So fine. So what you're just left to do is simplify. What is, if you simplify this one, you see that you arrive at 3x cubed. Then here you get what? 3x raised to power negative 3 over 2 plus 1 should give me what? It should give me negative half, isn't it? Okay, over, so this one should be positive. So this, is that fine? So here also it should be negative. 3 can go into 3. So you have negative 7, negative 3x over what? Ln 7. Then here 4 can go into 4. You have negative ln sec 4x minus 3 sec. Okay. So you see what I'm doing, I'm oversimplifying, okay? But if you leave your answers maybe here and just add those exponents, they should still give you your full marks. Okay, so that is how to integrate that one. Right. So that was how to integrate that one. Yeah, so that is how to integrate this one. So these are this is what's expected of you in the exam. Yeah. So that's how to integrate. So let's move to the next question. All right. Now there are some situations as well where they normally say simplify. Okay. Okay. Topic is simplify using integration. Okay. Using integration. So what do you need to know? You need to know that things we need to know. Okay. We need to know that when you have a plus 2a, I'm sorry, what am I writing? Okay, we need to know that when you have a squared plus 2ab plus b squared, it's equals to a plus b all squared. Then we need to know that when you have a minus 2ab plus b squared is equals to a minus b all squared. Then what do you need to know? You need to know your trigonometric identities. There are so many of them. Okay, I won't write them out. You need to know your trigonometric identities. Okay, because what the question will just say simplify. Okay, so you need to know your trigonometric identities. All right, you need to know your trigonometric identities. Then other forms of exponent laws, you need to know them as well. Because that's what the question will just say. The question will just say what? Simplify. What do I mean? Look at this question. Look at this example. Example. All right. So it is just say simplify. Okay. The integral of the square root of x squared plus 4x plus 4x. So we have to simplify that expression using integration. Okay. We have to simplify that expression using integration. Now, what do we do here? Okay, there's no for your level, there's no rule for this one. So what we have to do is simplify the expression here first. Okay, by factorizing this. All right, we have to factorize that first. Okay, we have to factorize that first. How do you factorize it? by using the first rule I wrote. Okay, yeah. So if you see, this should give you what? The integral of the square root of x plus what? 2 all square. Okay, it should be that. You should have that as an answer. You have what? X plus 2 all squared dx. Okay, but you see, you're already square, you're rooting it. Okay, so because you're rooting it, what will happen to this square? It falls away. So you have the integral of what? Let's say it's x raised to x plus 2 all squared. Okay, then to the power of what? Half. Understand? So this one will cancel this one. So what are you having? You're having the integral of what? X plus 2 dx. Okay, so you can integrate this one. This is the same thing as x 1, 2 squared plus what? 2x plus c. Okay, so it's 1 plus 1 over 1 plus 1. So that is how to solve. So you are supposed to simplify by using integrations. Is that fine? That is the main thing. Now, you might have identities, you might have just a simple integration, but the question will say what? Simplify. So let me crop some questions out that I have selected for this one. Okay, so you can see this is a question. It just says what? Simplify. Okay, it just says simplify. So with this one, what do you use? You use your what? Exponent laws. Is that fine? You use your exponent laws. Why? Because we know that when you have 1 over x raised to the power n is equals to what? X raised to the power what? N x raised to the power minus n. They're fine. So you see, it's the t. You're supposed to integrate with respect to t. The rule still applies. Okay, so start solving. These ones are easy. Okay, start solving it. Then you have this one here. Okay, with this one, what are you supposed to do here? You're supposed to factorize that quadratic equation there. You're supposed to what? Factorize. Is that fine? Please do it. Okay, so there's that one as well. Okay, you're supposed to integrate normally. You don't need to use any identity, just integrate it normally. So the question will just come as what? Simplify, or you're using integration to get an answer. Okay, you're using integration to get an answer. Let's look for some hard ones. Okay, so you see, these are just examples of what we will need to do. Okay, so the question comes out as what? Simplify. But you're using integration to simplify the problem. That's fine. You're using integration to simplify the problem. All right. So that's how to do it. Okay, now so let me start with this one first. Look at this one. Is that fine? So we are supposed to simplify and what? Integrate. Is that fine? So let's simplify the question first, then we integrate whatever we have left. All right. So we have the integral of, how do you simplify this one? You know that when you have a plus or minus b over c, you can say it's the same thing as a over c plus or minus what? B over c. So this is the same thing as saying 7 cos x sine x over what? Cos squared x plus 9 over cos squared x dx. Okay, so if you cancel out, this will cancel this one. Then you're left with what? The integral of 7 sine x over cos x plus 9 cos squared x dx. Okay, then you apply your identities here. If you apply your identities here, you have what? 7 tan x plus 9 sec squared x dx. Okay, you can integrate this. Okay, how do you integrate tan? The integral of tan is what? 7 ln sec x. The integral of this one is 9 tan x plus c, and that is your final answer. Okay, so that is how to simplify. Okay, simplify using integration. Okay, so those are those questions that come up. So you can solve the remaining in your spare time. Okay, if you have any question, you can just mail me or send me. No, I don't have SMS. You can mail me and I will help you. So you see with this one, for the first one, yes, you're just supposed to integrate what t to the power of -7, the t. Then you integrate that. Then here you factorize this one, square root it, integrate. Then here you don't need to use any identity. You can just integrate this one easily. Then here you just open the bracket and integrate, and you get your final answer. Okay, so that is what you're supposed to do. So that's simplifying using what? Integration. Okay, it's just a different question, but it's still the same rules. Is that fine? It's just a different question. Remember, what they do is that they put they solve it into different parts. Okay, so if you look at the textbook as well, there are also questions there that I saw there this morning.